All right, good morning, KNES 310 class. Today, get into my announcer voice. Today, we are going to try to put a bow on all of the information we've been learning, get you ready for the test. So today is going to be practice and taking all of our concepts and putting it all together in application, okay? So this exercise, it's just a still picture. How can we infer motion? Well, there's a few ways. You need a little bit more information, but there are some things we can talk about with just this still picture, like the fact that his right elbow is flexed. Okay, that's his right. We analyze motion from the perspective of the observee, not the observer. If I'm trying to help someone, it's their body, it's their joints, it's their muscles, okay? So right side, joint, elbow, position, flexed. Flexed based off of what? Anatomical. His elbow is more in the fetal position than anatomical position. He's flexed. Now, how do you qualify the magnitude of being flexed? Well, that's where you get into goniometry and angles. So you'd say he is flexed, you could actually measure it, but flexed 90 degrees from anatomical. So you could actually, there's markers for the metaphor of miles, right, in angles and degrees, okay? His elbow is flexed. Now, how do we infer motion with a still picture? So you need a little bit more information. The information you need is from this starting position, is he moving towards anatomical or does he start to move away from anatomical? He's already away from anatomical, but does he move further away from anatomical? Okay. So on the test, if I say from this position, you observe motion towards anatomical position. Well, then I know that he must be extending his right elbow. So in terms of motion, he would undergo right elbow extension as he brings his elbow from this position to anatomical. Now, the entire time he's moving, up until the point he gets home, he is still flexed. Even though he's moving in a direction of extension, he's still more in fetal position than anatomical. Okay? If I say from this position, he begins to move his elbow away from anatomical, then you'd say he would be undergoing right elbow flexion, more into fetal. He is more into fetal here than he was here. So therefore, the direction of motion from this position to any of these positions is more flexion. Okay. Now let's talk about planes and axes. How do you and I, assuming I'm inferring, I'm looking like this and you're looking at this, if he moves his elbow to and away from anatomical position, flexion, extension, the part of that general motion that is rotational is occurring in which plane of your view? How do you see this flexion and extension? You can press pause if you want, and then come back if you want to try to think about it. We, you and I, observe this flexion and extension in our frontal plane. We see frontal plane rotation about an anterior posterior axis. He sees, now let me put some inference here, let's infer that he's looking this way. So I know some of you smarties over there would be like, well, what if he's like this, right? So let's infer that he's looking in the direction of his curls, right? He doesn't see frontal plane. He sees sagittal plane about his bilateral axis. Through his right, out his left. His side by side, our front to back. Both of us are correct because we communicated the perspective. Okay? Now, if I globally, this would be in this rooms, because this is the front of the room, right? Where you lecture is the front of the room. So this would be the classroom's frontal plane also. So you, I, and the classroom would be seeing the same thing. It's hard for me to give you global in class. If you were taking this class in person, I can give you more global type questions because we can establish front of class, side of class, up, down. Probably going to stay away from sagittal and frontal global plane questions to you because you could be taking this test anywhere. You could be in your car getting Wi-Fi from the library. You can. So I'm not going to ask you global sagittal, but we can establish what global transverse is, right? Because that's reference to ground and gravity. If you think about the direction of gravity serving as a polar axis, and transverse plane. So globally, I could ask you a transverse plane question. Okay? Be right back. Go and change the picture. Ooh, so many questions here. Now remember, this is kind of cool because this is planting a seed on what's coming and a lot of different motions, a lot of different joints. But on your first test, I told you that all we're doing is practicing these concepts with sagittal plane motions and positions that get you into a ball and out of a ball. Specifically, wrist, because that's easy, elbow, that's easy. Probably not going to go to shoulder because there's some trickiness to what's flexion and extension. Knees, hips, okay? So let's go to some elbow questions, okay? We'll go my left to right. So we'll start there. And if I said, what is happening? So this is an example of a before and after picture, okay? Let me get my laser pointer here. Start, finish, start, finish. Now, eventually you're going to be able to analyze. Well, you may be saying, well, there's a lot of things moving there. No problem. We analyze motion joint by joint. And so on the test, I'd say, what is the motion of the elbow from there to there? You'd say, okay, side joint motion. We're talking about his right elbow. He starts in an anatomical position from the elbow's perspective. His shoulder's not an anatomical, but this isn't a shoulder question. Like my mom used to say when she was fussing at me, like, but my brother. She's like, this ain't about your brother. It's about you. So if this is an elbow conversation, we need to see the shoulder's way out of this conversation until it comes time to talk about the shoulder. So the elbow starts in an anatomical position. Does it stay in an anatomical position? No. From left to right, now that elbow is more into fetal. So it went from anatomical to fetal. Even though we didn't see it, we can infer it. Because the only way to go from point A to point B is to have elbow flexion. So from here to there, we had right elbow flexion. I'm not disrespecting what the shoulder did. I'm just respecting that the conversation right now is about the elbow. And all the other stuff is a distraction to analyzing the elbow joint's motion. What if on the test I tried to trick you and I say, hey guys, we're going to start here. We're going to start on the photo on the right and go from here to there. And you say, well, that's easy. I started off in a flexed position and I went to an anatomical position, so I had to have right elbow extension. Cool. Planes and axes, again, we see frontal, he sees sagittal. Both of us are correct because we communicated perspective, right? Here to here, right elbow extension, right elbow flexion. Here to here, bilateral, both sides. This was his right, this was his right. Now this is his right and left. Bilateral elbow flexion. Bilateral elbow extension. Same thing, our frontal, his sagittal. Sticking to the elbows. Bilateral elbow extension. Bilateral elbow flexion. Let's go to knees and hips. From here to there, more fetal than here, correct? Bilateral hip flexion, if we're analyzing the hips. And then we go back, bilateral hip extension. Let's analyze the knees. Bilateral knee flexion, bilateral knee extension. Okay. Here we are in a flexed position. Here we are in anatomical position. Okay. Let's do a static picture and infer motion. From here, you observe the weights coming down. What would be happening to his elbows? Press pause, give it some thought. Welcome back. If he's bringing the weights down, you're going to observe bilateral elbow flexion. Now, this is where we're all seeing the same thing, because now he's looking at you and you're looking at him and I'm looking at you and he's looking at me and it's all crazy. But we would all observe the rotation occurring in a frontal plane, assuming he goes this way. You'd be like, well, what if he does this? I'm going to communicate. I'm going to make sure to give you enough information so that there is no detour on this crazy winding road we're in. Okay? Bringing the weights up, bilateral elbow extension. Let's check this out. Well, this isn't bilateral. This is just the side. Now, this is a good example of understanding that you're analyzing this person's motion. Some of you on the test are going to get confused on this and you're going to miss it. And I'm going to be like, I'm going to wag my finger. I'm going to be at my house and I'm going to be like this. This is not his left arm. This is his right arm. It's your left as you see it, but this is his right. So if I'm analyzing motion of his elbow, I'm going to say from left to right is right elbow flexion. Right elbow extension. Now, hopefully some of you are like, that's not in a specific plane. You're absolutely right. This is in a combination of planes. Just like you can go northeast, northwest, southeast, southwest, you could go in a combination of straight lines. You can do combination of plane. This is all sagittal. This is all frontal. This is a combination of sagittal and frontal. Some of it is sagittal spin, some of it is frontal spin. That's okay. It's not a separate dimension. Then you'd have infinitely many dimensions. So it's just a combination. Some of that spin is sagittal, some of that spin is frontal. It's all good. Let's go down. Okay. Left to right, bilateral elbow flexion. What plane? Press pause. This one's going to be fun. We see this as frontal. Let's infer that he's looking down because he's kind of up and we don't really see his eyes. And so let's put some givens in here. Let's say he's looking down and he goes from here to there. His elbows are rotating in his transverse plane. If he's looking down on the ground, his transverse, our frontal. Bilateral elbow flexion, bilateral elbow extension. Here, he is in a flexed position. His elbows are bilaterally flexed. All right. Be right back. Go and switch the picture. All right, going to get on this side so that you can see. All right, so here we need to establish side joint position, and then when I give you fetal out of fetal, then we'll get into motion. Okay, so press pause and try to tell me what is the position of her hip. Okay. Welcome back to my channel. This is her left hip. How do I know? I could literally see the curve in the seam of her pants. What is the position of her left hip? Her left hip is extended. Her left hip is further away from fetal position than even anatomical. That's what extended means. You're further away from anatomical position. Now, how do we infer motion? From this position, she starts to rotate her hip towards anatomical position. She goes home. Well, that must mean she must have left hip flexion to go home. I could say this. She starts in anatomical position and moves her hip to this position. So instead of starting here, she finishes here. Well, that motion would be left hip extension. Inference of motion. Let's talk planes and axes. If she's rotating that left hip to get to here or move from here, that is our frontal plane spin, but it's her sagittal plane. It's her hip sagittal plane for sure. Okay. What's the position of her elbows? Flexed. What is the position of her knees? Her knees are in anatomical position. Okay. I'm going to get into extended in anatomical position in more details when we go into the rest of the joints. Because again, some joints, your end of your range of motion is its anatomical position. But I'm not going to hold you accountable to that for the first test, okay? So you could just say her knees are home. Her knees are in anatomical. From their perspective, look, the knees have no clue what all the rest of the body's doing. They have no clue. They don't know. All they know is that, hey, I'm home. I don't know if they're home. I don't care. I don't know if they're home. That doesn't matter to me. I am home. The knee is in its anatomical position. Let's talk about the wrist. What's the position of her wrist? Now, for some of you that are like, oh, well, which wrist? Well, there's only one, I'm going to communicate that. But on the test, if I say, what is the position of the wrist that is not in anatomical position? Well, there's only one wrist that's obviously not home, and that is this wrist. Which wrist is that wrist? Her left. Her left wrist. What's the position of her left wrist? Her left wrist is extended. It's in an extended position. Where is it at? It is extended. Well, how did she get there from anatomical position? She had to undergo extension. Okay? And then if I said she gets done stretching her muscles of her wrist and she goes from an extended position back to anatomical position, well, then she must have flexion. So let's tie it all in a bow. Her left wrist is extended. Getting to that position from anatomical, she'd have to have left wrist extension. Getting from this extended position back home to anatomical, she'd have to have left wrist flexion. Getting the hang of it? We analyze motion joint by joint. Sorry, I didn't mean to hit puberty right there. We analyze motion joint by joint. Her right knee is flexed. Her right ankle is plantar flexed. You're not going to know. You not need to know ankle joint on this first test, but I'm just babbling. Both her hips are flexed, so she's bilaterally flexed at her hips, but her left knee is in anatomical position, and her right knee is flexed. Make sense? We analyze motion joint by joint. Someone who isn't trained to see or understand human motion just looks at this and, man, it looks all contorted. But you take a Rubik's Cube, you know the little Rubik's Cube that's all contorted, and you give it to a Rubik's Cube master, and they can put it all back nice and clean and in order again. Thank you for those that said, bless you. So it's the same thing. This is confusion. But once you learn how to analyze joints, their position and their motion joint by joint, it won't be confusing. You'll just know that you got to start someplace, and then you analyze motion and position joint by joint. Okay? All right, so that's my examples that I have for you guys. My homework, it's not really homework, just practice. Go in the weight room if you can, or take out some dumbbells at home if you can, or if you don't have dumbbells, big whoop, go grab a can of corn. Grab something. It could be anything. And practice motions and position in your sagittal plane that would constitute going into fetal and out of fetal. Again, on the test, wrist is fair game, elbow is fair game, knee is fair game, hip is fair game. Because I got to introduce you to these concepts of what position are you in and where are you moving, okay? And the last thing I'll leave you with is, remember, you can be extended and be flexing. Nothing wrong with that. Just like I could be east of Lafayette but be traveling west, no problem. I can be flexed and be extending. Nothing wrong with that. Just like I could be west of Lafayette but be moving east. No different, okay? Let me know if you have any questions, and we'll see you next time.